Okay, today's lesson is solving systems of inequalities, and the numbers I'll be doing are 1, 5, 6, 8, 12, and 15. Now I want to remind you about steps to solve linear systems of inequalities. We've actually done this before when we did our targets, so let's remember here what we did. The first step is to graph the lines with the method that you're most comfortable with. And remember, that's maybe getting the y by itself and making it y equals, or making a table and finding some points, or using the intercepts as your points, making x and y 0. So whatever method you're most comfortable with, graph those lines. And when you graph the lines, remember you want to change that inequality into an equation. When you graph the line, it's going to be equal, not a less than or greater than. And secondly, you're going to shade above or below the lines by testing a point that's not on the line, like 0, 0. And you test that point in the inequality, not in the equation. And the solution to a system of inequalities is where the two shaded portions overlap. Now let's look at our examples. So on number 1 here, I've got y is greater than x plus 1, and y is greater than 2 minus x. Now again, remember that the first thing I want to do is graph my lines. Because both of these inequalities have y by themselves, I'm going to use the method of finding the y-intercept and using my slope to find the next point. Now remember, to graph my lines, I want to change these inequalities right here to equal signs. So it's really y equals x plus 1 and y equals 2 minus x. So on my first equation, y equals x plus 1, my y-intercept is 0, 1, and my slope is 1 because the number in front of x is a 1. So I'm going to start on 0, 1 here, and then go up 1 and over 1, and that will be my line. So I'll draw a line between those 2 points. Now I'll test whether I'm supposed to shade above that line or below that line by testing 0, 0 in my inequality, since 0, 0 is not on my line. So I wrote the first inequality down, y greater than or equal to x plus 1. Now I'll substitute 0 and 0 in place of x and y. So when I substitute 0 in place of x and y, I end up with the statement 0 is greater than or equal to 1. And that's a false statement. That means I don't want to shade 0, 0. So that means since 0, 0 is below the line and I don't want to shade that, I'm going to shade up here above the line. Now I'm ready to graph my second line. On my second line, my y-intercept is 0, 2, and my slope is negative 1 over 1, since this number in front of x is negative 1. So I'll start on my y-intercept of 2, and then I'll go down 1 and over 1, and then I'll graph that line. So I've got my line graphed for my second line, and if this was asking for the solution to the system of equations, it would be where the two lines cross. But right now I need to find out about shading for my second line. Do I shade above the line or below the line? I'm going to test 0, 0 to find out. So I've written down my second inequality. Now I'll substitute 0 in place of x and y. After I substitute 0, 0 in place of x and y, I end up with this statement 0 is greater than or equal to 2. And again, that is a false statement. So that means I don't want to shade 0, 0, which is below my line. I'm going to shade above my line. So the solution to the system is this part where the two shadings came together, where both colors came together. That is the solution to the system of linear inequalities. By the way, the button that you use to shade is this button. Okay, so now I'm moving on to number 5. And this time y is not by itself on either one of these inequalities. Remember, I need to graph the lines first by making these inequalities equal. So I think the method that I'll use this time is to create a table, and I'll try to use my intercepts. And if that doesn't work for some reason, or it gives me fractions, then I'll go ahead and use another number that I can figure out. So I've changed my inequalities to equal so that I can graph my line, and I've set up a table for both equations. And now I'm going to substitute, and I always start by substituting 0 because 0 is always the easiest thing to come up with. So I'll substitute a 0 in place of x for my first equation. So if x is 0, I need to find 5 times a number that's equal to 0, and that's going to be 0. So 0, 0 is one of the points on my line. Now I can't use 0 again because if I put 0 in place of y, then 5 times 0 is 0, and that's the same point that I already have. So I'm going to use a different number for y. So I'm going to put a 1 in place of y this time. And 5 times 1 is 5. So another point on my line is 5, 1. So there is that first line graphed. Now I'm going to test a point for that line to see which side of the line I should shade, either above the line or below the line. Now, one of the problems on this one is I can't test 0, 0 because it's on my line. So I think I'll test 1, 1. So to test my point, I set up my inequality, which is the first one, x greater than or equal to 5y. Then I substituted 1 in place of x and 1 in place of y so that I can test that point. And when I do that, 5 times 1 is 5. So 1, I have the statement 1 is greater than or equal to 5, and that's false. 1 is not greater than or equal to 5. Now 1, 1 is here, so I don't want to shade that point since the statement was false. So I'm going to shade below the line. I've shaded below the line there. Now I'm ready to do my second equation, draw the line for my second equation. So I'm going to start again by substituting 0 in place of x and figuring out y. So if I substitute 0 in place of x, then I've got 3y equals 9. Divide both sides by 3. So y is equal to 3 if x is equal to 0. So 0, 3 is one of my points. Then I'm going to substitute 0 in place of y this time. So if y is 0, 3 times 0 is 0, so I just have x equals 9. So 9, 0 is another point. Now I'll graph those 2 points to make my line. Okay, now that I've graphed that line, I hope your line's straighter than mine, then I'm going to test a point to see whether to shade above that line or below that line. Now this time, because 0, 0 is not on the line that I just drew, I can test 0, 0. So I've set up my inequality, x plus 3y is less than or equal to 9. Now I've substituted 0 in place of x and y, and I'll simplify. When I simplify, 3 times 0 is 0, and 0 plus 0 is 0. So I have the statement 0 is less than or equal to 9, and that's a true statement. So we need to shade where 0, 0 is, which is below this line. So I've shaded everything below that line. So the solution to this inequality is this area right here that is below the line and where the two colors came together. Okay, looking at number 6, again, these inequalities don't have y by themselves. So again, I think I'm going to use the method of making a table to create my lines for these two inequalities. Okay, so if I substitute 0 in place of x in my first equation, then I know that y is also going to have to be 0, because the only thing you can add to 0 and get 0 is 0. So 0, 0 is one of the points on this line. That means I'm going to need to substitute a different number for x or y, because so that I can find another point besides 0, 0. So I think I'm going to substitute 1 in place of x, and 5 times 1 is 5. So I know that I'm going to have to add negative 5 to that 5 to make this equation equal 0. Now I'll graph those 2 points. Now I've graphed the points to make my line. Now I'm ready to test a point in my inequality to see which side of the line I need to shade. I can't test 0, 0 since it's on my line, so I'm going to test 1, 1. So I put 1 in place of x and y, and I simplify. 5 times 1 is 5, and 1 plus 5 is 6. And so I end up with the statement 6 is greater than or equal to 0. And that's a true statement. So I need to shade the side of the line that contains the point I tested, which is 1, 1. So I've shaded the right side of this line. Now I need to find some points for my second line. So again, I'm going to start by substituting 0 in place of x. When I substitute 0 in place of x, I have negative 2y equals 6. When I divide both sides by negative 2, I end up with negative 3 for y. And I know that negative 2 times negative 3 is positive 6. So 0, negative 3 is one of the points on my line. Now I'm going to substitute 0 in place of y, and that leaves me with 3x equals 6. So 3 times 2 is equal to 6. So that means that 2, 0 is another point on my line. Now I'll graph those 2 points to draw my line. Now that I have my line graphed, I'm going to test a point to see which side of the line that I need to shade. And this time I can test 0, 0 since it was not on the line. When I substitute 0 in place of x and y, I have 3 times 0 minus 2 times 0. Both of those equal 0. So 0 is less than or equal to 6 is a true statement. So I'm going to shade the side of the line that contains 0, 0. So the solution to this inequality is in the portion of the graph that contains both of those 2 colors, which is this portion of the graph. Okay, on number 8, I've got x is less than or equal to 9, and y is greater than or equal to negative 6. I'll start by graphing those lines, and remembering that x equals is a vertical line, and y equals is a horizontal line. So my line x equals 9 is graphed. Remember, it goes through the x-axis at 9, 9, 0, and another point is 9, 1, because x is always 9. And now I can test 0, 0 in that inequality to see which side of the line I should shade. So 0, 0 makes this a true statement because 0 is less than or equal to 9. So I'm going to shade the left side of this line. Okay, so now I'm ready to graph my y equals negative 6 line. Remember, that's a horizontal line. So I'm going to draw that through the y-axis at negative 6 horizontally. Now that I have my line drawn, I'm going to test 0, 0 to see if I need to shade above or below the line. When I substitute 0 in place of y, 0 is greater than or equal to negative 6, so I'll shade 0, 0. So the solution to this system of inequalities is this portion of the graph where the 2 colors came together. So it's in this portion of the graph. Now, one thing I want to caution you about is all of the examples that I've shown you here have said less than or equal to or greater than or equal to, which means that the lines that we've done have all been solid lines. But remember, if it just says less than or just says greater than, then it's a dashed line. Okay, the next example I want to show you is a multiple choice, number 12. And I've got two inequalities, y greater than or equal to 1/5 x plus 2, and y is less than or equal to 1/5 x minus 4. Now the first thing that I notice is that both of the slopes are the same in these two inequalities, which means that these lines should be parallel lines. So that eliminates one of my choices, which is choice D. Now remember that if we were talking about a system of equations, that would also mean that there would be no solution. But that's not necessarily true on a system of inequalities because of the shading might still overlap. These two lines don't overlap, but the shading might overlap. So we'll need to shade on both sides of this line to see which one is correct, either A, B, or C. So since they already have the lines drawn for me in B and C, the only thing I need to do is just test a point 0, 0, since it's not on either one of those lines. And the lines are the blue and red on these choices. I'll test 0, 0 and find out if the shading meets or not. Okay, so if I test 0, 0 in my first inequality, substituting 0 in place of y and 0 in place of x, I get 0 is greater than or equal to 1/5 times 0 plus 2. 1/5 times 0 is 0, and 0 plus 2 is 2. So I end up with a statement 0 is greater than or equal to 2. That's a false statement. That means that I should not shade 0, 0. So that means that C is eliminated because my blue line is 1/5 x plus 2, and I know that because 0, 2 is my y-intercept, which means that that line should go through right here at 2. And so I should be shading definitely above that line. Now B has that done, but B also has the red line shaded below the line. And that those two shadings do not meet, which means that actually the correct answer is A. There is no solution to this system of linear inequalities. Okay, the last problem that I want to do is number 15. Number 15 says find the square of the expression. For example, the square of 7 is 7 squared, or 49. And the square of 5x is 5x squared, or 25x squared. So they want me to find the square of 9z squared. So that means that I'm going to take 9z squared and square it. Now if you remember from the very beginning of algebra that we, when we raise a power to a power, we multiply our exponents. Not forgetting that the 9 has an exponent. Its exponent is 1 if we don't see it. So we're going to multiply these exponents. So what I really have is 9 squared, and then because 1 times 2 is 2, and then z to the 4th, because 2 times 2 is 4. And 9 squared is 81, and then I just leave my z to the 4th. So the answer to this expression is 81 z to the 4th.